we compute sample covariance S sub xy and sample correlation coefficient R. Data x takes on these values, y takes on these values. 5 observations, we have 5 rows where x is 6, y is 6, where x is 11, y is 9, etc. Summation of the x column is 80, therefore the average is 80 divided by 5, which is 16. So this is x bar. Summation of the y column is 50, therefore 50 divided by 5. So this right here is y bar. Now we compute the sample covariance is you must take each of the x value, the difference between each x value and its mean, the difference between each of the y value and its mean, multiply those two columns, sum it up, and divide by n minus 1. We'll continue. X minus x bar column is computed here. The numbers would be 6 minus 16, which is negative 10, 11 minus 16, negative 5, 15 minus 16, negative 1, 21 minus 16, which is 5, and the next one would be 11. The next column is y minus y bar that we compute. 6 minus 10 is negative 4, 9 minus 10, negative 1, and we continue and we fill the column. The next thing is, as the formula says, we need to multiply the differences that we just computed. So the x minus x bar column, the x minus x bar column must be multiplied by the y minus y bar column. I don't know why I keep doing this. Minus the y minus y bar column. Therefore, negative 10 times negative 4 is 40. Negative 5 times negative 1 is 5. And then we have 4 and 35 and 22. Then we need to sum it all up. As the formula says, the summation of this column is 106. So to compute the sample covariance, you take the 106 and divide it by n minus 1. And remember, our sample size was 5. So 5 minus 1, which is 4. So 106 divided by 4 gives us 26.5. And that right there is your sample covariance. Now keep in mind that in here we had both negative signs, so negative times a negative gave us a positive 40. And the same thing for the next row and the next row. If any of these products ended up being a negative, then in the summation of it, maybe we would end up with a negative numerator, and therefore our covariance could take on a negative value, which represents a negative relationship. Now we continue on and use the sample covariance in computing R, or the correlation coefficient, for the sample. The formula is given to you right here using your textbook. So we can see that we've computed the covariance, which is 26.5, but now in the denominator we need to compute the standard deviation of x and the standard deviation of y. So we continue to compute the standard deviation of x. We need x minus x bar squared. So x minus x bar column was computed here. This is the third column, negative 10, negative 5, negative 1, 5, and 11. All we have to do is score them, and we get 100, 25, 1, 25, and 12, and 121. To compute the standard deviation for x, we need to sum up this column, which gives us 272, and then divided by n minus 1, which is n minus 1 is 4. I'm gonna I'm running out of room here, so I'm going to create some room here by erasing some of this. Okay. So standard deviation of x is the summation of the x minus x bar column squared divided by n minus 1, which in this case is 272 divided by 4, which is, I'm sorry, that's the variance for x, which happens to be 68. Then if we take square root of it, the standard deviation of x would be square root of 68, which is 8.25. So 8.25 goes in the denominator. Now we need to compute the standard deviation for y, so we need y minus y bar column squared. We have the y minus y bar column, but now we need to square it. So negative 4 squared is 16, and then we fill the rest of the entries. The summation here is 86. So again, we can compute the standard deviation for y. So the variance for y is the summation of the y minus y bar column squared divided by n minus 1, which in this case it would be 86 divided by 4, which happens to be 21.5. Now the standard deviation of y would be square root of 21.5, which is 4.64. We'll put that in the denominator. And if you go through that math right there, your sample correlation coefficient would be approximately 0.69.